Okay, thanks, Dobbs. Morning, everyone. Welcome to our iTuesday this morning. We're joined by the infamous Mr. Martin Vass. And on the call, we also have our senior underwriters in the PI and General Liabilities Division, Susie and Fiso. And today we're going to be talking about tailing dams. So a little background into what a tailing dam is. To be honest, Martin, when you first approached me a few months ago regarding tailing dams, I was in the dark about what it is. But now I feel like since you started talking about it, I've done so much of research into it.
Right. Do you want to carry on with the talk then?
No. So a tailing dam is used to store byproducts of mining operations. And apparently they rank amongst the largest engineered structures on Earth. That I didn't know.
That is
and
correct.
they're designed for permanent containment of mining materials.
Yes.
And they're meant to outlive us, apparently, Martin, is that correct?
I'm afraid not only outlive us, outlive our children, our grandchildren, the great-grandchildren.
And everybody, yes. Or outlive the human race.
Yes, not quite. Well, one hopes not, but they're going to be around a long time, yes.
Okay, so why are tailing dams trending and what are the concerns around them? So according to Reuters, data shows that more than a third of the world's tailing dams are at risk of causing catastrophic damage to nearby communities. Apparently, that's a total of 687 tailing dams which are at risk. And the consequences of tailing dam collapses can be both immediate and long-term. And the immediate effects are obviously the loss of life. Long-term is other impact that they have on the ecosystems and the surrounding environment.
Yes.
Yeah. So today, we love to learn through examples, and this is why we love Martin the most. Martin Vass joins us, and he's going to illustrate some real-life tailing dam failures, as well as the grim aftermath. So sit back, relax, let's get some popcorn, and let's get started. Over to you, Martin.
Have your Coke and your popcorn ready. Yes, Tommy, thank you very much for the introduction. I'm just a little bit, and just to pick up what you're saying, how long did you, and please, I would ask anyone to ask questions as we go along. Don't wait to the end. So if anyone wants to put their hand up, please ask as we go. Yes, you said they're going to be around at least as long as we are, and maybe our children. When they do the original tailings dam designs, they actually have to design for an earthquake for a 1 in 1,000-year return period. But as far as we can understand at the moment, the tailings dams will be around for a period of about 10,000 years, which is about twice the life of the pyramids. Because really, we built these very, very large structures, as you quite rightly say, some of the largest structures on Earth, out of crushed rock. So they're not going anywhere. You can't dig a hole and bury them, because then you end up with the material from the hole. So there's very little you can do with these tailings dams. And the worry, and I'll go through the various examples just now, the concern we have now is that when the mine is operational, then there are people to monitor it, to control. And the biggest problem, I'll get through it just now, to control the ponds actually lying on top of these dams. And when the mine is in operation, there is really no problem. And the mine has to set aside finances, in fact, to rehabilitate these tailings dams, and that involves changing the slopes on the dams, etc., etc. But when the mine has been closed for some years, who's going to look after these dams? In many cases, these mines close. The mining house, in some cases, close. We've had recent cases, certainly in South Africa, where people have bought the mining house, has stripped the money out from the mining house, the rehabilitation money, and has left the company really sitting in with no money and no way of looking after these tailings dams. And it is a problem going forward. And certainly the tailings dams, we've had some very large structures in South Africa, but overseas they have the same problem with tailings dams. And I'm going to show you some of those examples from overseas. Just give you one, there's a tailings dam in Canada, which has a length of 18 kilometers. Now, we don't have that kind of size dams here, although the ones out at Springs are what we call a new super dump. That is a very large tailings dam. So who's going to look after these going forward? What are we giving our children? What are we giving our grandchildren to look after these? I mean, some of these tailings dams already are quite old, and nothing's changed at all. I mean, they're exactly as they were when they were constructed. although we have had the failures, which I'm going to show you just now. So let me kick off. And really, I'm going to kick off and show you how a tailings dam is constructed and what happens during the failure of a tailings dam. So I'm going to start off. I'm going to press a button here, and I hope I don't lose everyone, and hope we bring up the next one. Yeah. Okay. So what we've got here on the right-hand side of this photograph are the blue, which you see a 4 written on. These are really the starter walls or the starter dams, and these are earth embankments. Try to keep them impervious, and you start off where I've got written the letter 4. That is really your starter dam. So you build that dam, and then after you've built that dam, you can start depositing tailings behind the dam. So, and you'll see just now. So as the tailings increase and as it gets near the top of the starter dam, then you extend the size of that starter dam. But if you look at the very top of the blue there, you must always keep a freeboard. You must always keep a 1.5 or 2 meter between the top of the tailings material and the top of the dam you're building. That prevents overtopping during heavy rainfall. And in fact, it's one of the reasons we've had the failures on the local dams is these dams have overtopped. There are other reasons, there are other ways these dams can fail, but that is certainly locally, that has been the problem. There's an insufficient freeboard and the things are just overtopped. When they overtop, they then scour away those starter dams or the dams supporting the tailings, and then the tailings material itself then starts to run away. And you have to, this material is not sand. And as you said in your introduction, it's from the operation of a mine. This material is actually crushed rock. So when the water comes out of that material gets very hard indeed. You can't use a shovel to dig it. It's not like a sand pit that you can dig it. It's crushed rock. And to give you an analogy, if you go onto a beach, on a normal beach down in Plato, wherever you happen to be, as the tide goes out, the water drains very rapidly from that surface. Within a moment, you can walk on it. You don't sink into it. And this is the same with tailings material. It's crushed rock. When the water runs out of it, it gets very hard indeed. You can walk on it within a moment. And that is a problem after the failures. And I'll show you certainly on Mary Strait, where we had quite a substantial failure. That was the problem, that the people were caught in that material, suffocated, drowned in that material, and very hard to recover the bodies. So that is how a tailings dam is really built. You start off with your starter walls, your starter dams, and if you look on the bottom left, various methods of doing those starter dams to contain the tailings material. Here I've shown you, this is a diagram, and the major part is going to be the water on the right of the pond sitting on top of the dams. When you're discharging the material, and I'll show you how you discharge the material is discharged in a slurry. 70 or 75% of the slurry is water, the rest of the material is tailings material. So you're discharging this material onto the dam, and you must always keep, as I said to you before, the freeboard and this kind of sand beach area. So you must keep the pond away from the side of the dam, make sure it doesn't overtop. And you control the height of that water in the pond by a decant tower. And you see that on the right-hand side. So what happens, you control the level of the water by either lifting or lowering the height of that decant tower. The water then runs out of that and goes underneath the tailings dam into a return water dam. Into a dam, you can do something with the water. You'll never get it to be potable, but you can get it to be used back into the mining operation. So you can circulate that water. But as I said, this decant tower, if you leave that decant tower for some years without controlling it, the decant tower can get contaminated, get full of material, and eventually it doesn't work anymore. And even the discharge pipeline can also get full of material and again doesn't work. If you're leaving this dam for 100 years or 50 years, I don't know who's going to be looking after you. Who's going to go and control it? Who's going to monitor it? And when you design a dam, the original design, and some excellent papers, you want to go, SRK Consulting Engineers and Golder Consulting Engineers have done some wonderful papers on how you design a tailings dam, not just during the course of the operation, but long term. So when you design a dam, you must think of how that dam is going to work years in the future. So you've got to design it into the dam. And as I said, we design a dam initially, it's a 1 in 1,000 year return just on the earthquake. But these are around for thousands of years, these dams, and they're going to be here a long time. And you said quite rightly, it's not just the surrounding kind of the property damage initially from a discharge, but over a period of time, you've got contamination, and certainly I'll show you one in Brazil, contamination of surrounding, certainly the aquifer, the underground water supply, and also the rivers. You're discharging very toxic material if this overtops into the surrounding area. This is a typical starter. This is a dam, a typical starter dam here on the middle of this, and the material already starting being placed behind it. So this is the starter dam in front of you, and then on the right-hand side, you can see they've started depositing tailings material. Now, as they get near the top of this, then they'll add a further dam and so on and so on. They'll keep adding to this starter dam as the contained material rises. Here you see it quite clearly. This is a dam. They've lined it here to stop seepage through the dam wall. And that's another method of failure, which I'll get to a little later. If the material saturates that starter dam and eventually breaks through the face, you can also get failure of the starter dam as well. And you must be very careful of your phreatic water surface. So you must always have your surface of your water below the base of the dam. So it's in the ground, not exiting through the face of the dam. That will cause slumping, that will cause the dam to fail in itself. And I'll show you a couple of those coming up. You see, it's quite extensive earthworks, even before you start containing the material. So these dams are not cheap. You can see here, they're very extensive earthworks here to actually build your starter dam before any material is deposited behind. Here, there's a cut-off trench at the bottom, which takes any surface water away. It hasn't shown here, hasn't shown a pipe. I wonder if the next one will. Here on the left-hand side, you can see a series here. This shows very clearly how this has been in operation for some years, and they've slowly built it up, the starter dams. On the left-hand side, you can see the very small one at the bottom, and they've slowly added to it as the material is being contained, as the tailings material is being discharged behind these dams. So you've slowly built up the wall to control the material. Here you see it very clearly. Here's that little starter one at the bottom, and you see all these new ones which have been added to that original starter dam. And then on top there, you've got the tailings material contained behind that top dam. This is how the material, and I went back before. So this is the material coming from the mine itself. This is discharged. This is a slurry material. It's, as I say, I think it's about 75% water, about 25% material. And this water is the problem, not only handling it now, but going forward in the future. Because you not only have the water coming from the mine, but you have rainwater. So very heavy storm, you've got to have enough beach area, enough freeboard that a very heavy storm doesn't overtop the dam. And I'll show you the failure at Mary Strait. Mary Strait, which happened some years ago, the reason for the failure at Mary Strait is they didn't allow enough freeboard. And when they had the very heavy rains, it overtopped the dam, scoured up the dam, and then took out the tailings material. So that is one way of discharging. There is another way. I don't know where I got this. Is another way. You see here, this one they can move around. Sorry, going back. That one, this one is being discharged, but you can put a rubber hose on the end of that to move it around. This one here, you can see very clearly. This one you can move. It's on a stand. You can move it around, place it where you want. So this is the slurry that's coming out from the mine. And if you look behind, behind this is a tailings dam. The one behind is a dump. That's not a tailings dam in the background. Those are dumps. This is a tailings dam. This is slurry material coming from the mine. It's crushed rock. This walkway is not at Plet. You're not going out into the lagoon at Plet. This is to get to the decant tower. As I said, there's a tower in the middle of this dam which controls the height of this water. This is the walkway out to the decant tower, so that you go out there, you lift or lower the height, either by adding what we do in South Africa is add a concrete ring or take off a concrete ring to adjust the level of the water. But you see here the size of the pond on top of this dam. It's substantial. It's not just a puddle. This is a very large pond on top of these dams. And these are the problems we had. And certainly when we go around after the failures, and I'll show you some of the photographs, what some of these dams look like locally. And they are a problem here, or have been. I'm saying have been. After Maryspray, we did a very extensive research. Now here, this is an aerial view of a typical tailings dam. There's one above the other. You see the two tailings dam here. And you can see the ponds here. The ponds are well controlled. They're well away from the sides. These dams really have no problem at all. They haven't failed. Although the top left-hand one, if you look at there, the water is quite close to that edge. But the one in front of you here, the water is being contained quite nicely. Again here, you see a very large pond. Again, it's kept away from the sides. This is being well looked after. This is not a problem. This is quite an old dam. You see the vegetation is growing already. That's the other thing you have to be careful going forward. During the rehabilitation, during the long-term control of these dams, what is better to do, these are very steep slopes, as you saw from the previous photographs. And what they try to do is flatten out these slopes. Don't keep them so steep. And also you must watch the vegetation. The vegetation is very good for sand, for being blown by the wind. But what happens, the roots can also cause a problem. The roots inside the dam are not good. So really you've got to make sure this is just low-level shrubbery and no trees or anything are growing on the face, which can have a root problem in that dam. But that dam is well controlled, not a problem. We'll just have to come back and look at the vegetation going in the future. I don't think they've flattened that face well enough. I think further work could have been done on that. It's an old dam. At the moment, it's not a problem. Maybe in 50 years' time, 100 years' time, when you come back or your children come back, it may not look like that.
Martin, we've got one question from Heidi.
Please. Any questions?
She'd like to know what is the size of the mobile decant stand?
The size of the?
Of the mobile stand that you showed us a little bit earlier.
Oh, sorry, the mobile stand.
Yeah.
That one there?
Yes. Okay,
yeah, if you look at that, if you stand beside that, it's about 5 feet high, that stand. Sorry, I should have had someone stand beside it. It's about 5 to 6 feet high. It's not easy to move. It takes a couple of people to move it, but that is moved around. I have seen this actually handheld, someone's actually holding it, but normally it's like this, or the one before, which is fixed, and then they move a pipe around. So you see the rubber corrugated pipe here, that could be on the end of it, and they can move it around to deposit in various areas of the dam. You've got to put it around the dam evenly.
Thank you, Martin.
My pleasure. Okay, here's another dam. Again, you can see the size of the pond. The top one is fine. It's been kept away from the back, the front, and the left face, but it's a bit close to the right-hand face. The pond on the bottom here is fine. As far as the bottom of the dam is concerned, it's a bit close to the side on the left-hand side there. But these are line dams. You can see the lining in the dam, and that prevents seepage through the wall. So this is an operational dam. At the moment, there's no problem. If the people are on site, they can look at it on a daily basis. They can control the level of that water. Another one here, you see the water is all contained in the bottom left-hand corner. You try to dish it so the water is contained in the middle of the dam. And that is the problem going forward. And I gave a comparison with these pyramids. The pyramids are designed very nicely because they're nice sloping sides. So if it rains, well, it doesn't rain much in the desert, but if it does rain, then the water would tend to fall off it. Here, because it's a dish, If you have very heavy rains, the water is contained within that dish. And that is the problem going forward. And really, I don't know how you get over that problem unless you just monitor it on a regular basis. It really needs and I know there's discussion ongoing at the moment, a worldwide discussion about tailings dams, because we're getting more and more of these failures. And you said, I think you said 1/3 has problems. So if there's about 1/3 of tailings dam in the world, we could have a problem. Then we have a lot of damage going forward. It is a problem.
Martin, we have a question from Hera
Yes.
Gill. Which government department is responsible for ensuring tailing dam integrity is maintained?
Well, it's not really it's Department of Mines and Minerals, but it's really the mines themselves, and that is really, it lies with the mines initially. And at what point does the mine hand it over to another party? So you say responsible. Who's responsible for maintaining these? At the moment, it appears no one. Certainly the mines and the mines minerals, they would have to look at them and then issue an instruction for something to be done. But if the mine is no longer, the mining house is no longer existent, who actually pays? And maybe someone listening in could give an opinion on that. Who would then pay for rectifying the damage, and who will pay for doing necessary remedial work? Maybe someone would like to put their hand up and chip in on that. I'd like to hear a view on that. Because I know there is a worldwide body under discussion at the moment to monitor tailings dams throughout the world, which we haven't had up to this stage. But because of the failures we're having now, governments are taking notice of what the problem going forward. We have these problems, and the problems we're giving to our children and our grandchildren. So this dam in front of you, the water is contained on the left-hand side, better is contained in the middle of the dam, which then allows any heavy rainfall to be controlled.
Okay. So Lara Wild asked, during heavy rains, what do clients do to drain the excess water if there's anything they can do?
Yes, they can do. If the mine is, thank you, Laura. If the mine is still operational, if the tailings dam is still operational, as I said, you have the decant tower, and the decant tower controls the level of the water. So if you have very heavy rain, then you take off 1 or 2 rings on the decant tower, which then allows the water to flow off the top of the dam out into the return water dam. So that you can do. The problem comes when the mine is no longer operational. There's no one there to go out there and adjust the level of that water. And maybe for 20 years, maybe, if we have some money left over for the rehab work, maybe you can leave someone on site, and maybe an engineer can visit once a month. But I'm going forward now 50 years. And Laura, taking up what you're asking, in 50 years' time, who's going to go out there and adjust the level of that water? There's going to be no one around, as far as I can see at the moment, unless the government sets up a body to say, right, that's the body looking after these dams. And I know that's under discussion. It's going to be a worldwide body is going to put this into practice. How it's going to be implemented, I'm actually not sure.
So one more, Martin. Garth asked, Garth Dixie, why does the pond not dry out after closure of the mine?
Because of the rain.
Yeah.
If it's built in a very dry area, you're right, and it will dry out because it's a large surface area and it will dry out. And if it's not subjected to very heavy rainfall, yes, you're quite right, it will dry out. The material itself will take many, many years to dry out. But yes, the surface water will dry out. If it's not subjected to heavy rainfall, yes, then it will dry out. The pond will shrink and you may have no pond at all. All right, it'll be a dry. Then you'll have the decant tower just standing by itself, sitting up in the middle of the dam. Yes, that certainly will happen. Good question, thank you. Here again, well controlled. You can see here what's happening. The water is kept. There's a lovely big beach area here. There's no water adjacent to the dam. This is a well controlled. Again, this dam is under construction. People are monitoring literally on a daily basis. All right. So this is what I was trying to explain. These are the various types of failures. The one we've had twice here now, which is the overtopping. And that's the one you see on the left. That's insufficient beach area. They've allowed the water to overtop the dam. It then takes away that original dam that you built. The earth dam then disappears, and the tailings material can then go out, can cause huge amount of environmental damage. The other one on the right is called piping, and that is when you have a very small leak in the dam. So as I say, if you've allowed the surface area of the water to intersect the face of the dam, you have a small leak. If you have a piping in the dam, whether it's in the tailings dam or any dam, any earth dam, from a piping to the failure is very sudden. We had the thing called the Suknok Dam, which is down in Mpumalanga. And that earth dam was complete. They got piping at night. It was noted, the piping at night, and the dam failed in the morning. So the Suknok Dam failed in about 8 hours. So from the time you get that piping, that initial leak to the failure is very rapid, because as the water passes through the dam, it takes fine material with it. So it makes that hole bigger and bigger and bigger as the water takes away the fine material, and eventually you'll get the failure, which you see on the right-hand side there. And that's called a piping failure. So those are really two main types of failure: the overtopping, which we've had here, and the piping through the dam, which we had at Suknok Dam. These are various other ways. There's a slope failure. If the slope is too steep and the material gets very wet, it can slump down. It causes that slumping or slope failure, which you see on the left-hand side there. The overtopping I've discussed. This is now the failure of the decant tower. I told you that decant tower stands up and you control the height of it. That decant tower then goes out through the outlet pipe. The decant tower is a big problem. It's a problem also during operational, but certainly a problem going forward. That decant tower can get contaminated, get full of material, and is no longer operational. Then I can show you the piping, which is very common. Then erosion. Constant wind again. If you're leaving this thing for many, many years, you're going to get wind and rain erosion on the face of that dam. So those are the problems you're facing with these dams, and someone has to look after these, and it's going to cost money, a lot of money. You see the top dam has failed. The bottom one is still in shape, but you see the wall on the top dam, the one at the back, has failed. The fortunate part about this failure is the water and the slime material discharged from the top one into the bottom one. It didn't go over the bottom one. So this one was a contained failure. It shouldn't happen. That top dam shouldn't fail. But here we didn't have any death or environmental damage, but we did have a failure of that top dam. So that's the kind of failure which can take place. What's happened there, that top one has just slumped down. Going back to what we had just now, what's happened if the top left-hand one is what's happened on this dam. You've got that slope failure on that top there. You can see it very clearly. I don't know where you see it. Yeah, there. There, you see the slope failure has occurred. That material has slumped down, and it allowed a slight discharge of tailing material through there. But again, very small. This bottom dam is in place. The tailings material was contained within there, so that wasn't a problem. This is not, but I'm going to highlight, I brought this up for a reason. This is not a tailings dam per se, but this is the problems we have. Anyone know what this failure is? I'd love to, anyone can remember going back that far? It was a coal tip. Anyone going to take a guess where this coal tip was? What happened? These are, is someone going to come up?
Was that not in England?
Wales.
It was absolutely in Wales. Thank you very much. Thank you. And can you remember the name of the town? Thank you, someone. Can you remember the name of the town?
No, but I know it was a very bad accident. Lots of people died, and the Queen came afterwards. And
Oh, you're very good. Well done. Well done. I'll give you the name. It's called Aberfan. It was in northern Wales, southern Wales. You're quite right. And what happened here? They built these 6 very large tips above the town of Aberfan. And these were coal discards. These were no longer needed. It was waste from the mine, from the coal mine. And what happened here is that material got very heavy with the rain. You expect it in Wales. It got very heavy, and eventually the one of those dams or one of those tips failed, and it ran down into the town of Aberfan, and I think I'll show the next one. You can see where it's run in, and unfortunately it ran through a primary school and killed a lot of children. And Aberfan is remembered for that. You're quite right, the Queen went there. But where you see that long tail going into Aberfan town, underneath that is a primary school. It killed the children and killed the teachers. So I'm not trying to scare you to saying that's the kind of problem we have. The most tailings dams we have are remote areas. You know, they're out, although the one at Marysborough wasn't, they're out really in areas which is not occupied by, you know, housing, etc., etc. Although I say we've had it twice here and we have had fatalities. But this was a shocking one because a whole school was engulfed by this material. So, you know, this is the kind of legacy we're leaving, and we've got to look after. And as far as I know, the other 5 tips here have not been moved. They're still there, unless someone was to put their hand up and tell me differently. As far as I know, Aberfan still has that above it. So there we have a case of a lot of young children being killed by material left over from a mining operation. Very, very, very sad. Very sad indeed. Charmaine, thank you. This is Marysborough, which we were involved in. And what happened here is it was, as I said to you, it was very heavy rain. The control was not in place. At the time, this was an operational mine, and there was a company, in fact, looking after this dam, and they were taken to court. They were found guilty of culpable homicide because we killed, I think, 17 people within the town here, in the front of the town here. And you can see how far this material travels. I mean, the whole front face of that dam has disappeared, and you can see the size of the hole where the tailings material has come through. That material is wet. It's not dry material, it's wet, soggy material. It runs through the dam face of the dam wall here, but as soon as it stops flowing, it goes very hard. And where we had the problem here, we recovered the bodies, or the authorities recovered the bodies very quickly, except for one baby. One baby was brought under there. And we couldn't do anything, any remedial work until that body was found. It was found, I think, after about a week, and after that, we start tearing the place up. But here, following this, that wall has been rebuilt, and tailings material has been put back in there again. That was an operational mine. Following this, there was a court of inquiry held down in Virginia, and the insurers agreed at that stage that they would meet the fines of the 3 employees of the contractor. I'm not sure, and someone may chip in on that, whether in fact the insurers are liable to pay the fines. I think it's a criminal matter. I don't think they are. But again, someone may want to chip in and give an opinion on that. So that's what happened there. The 3 members of the contractors were found liable. They were not controlling the water sufficiently for the heavy rain, which allowed this to happen.
Martin, can I ask, Rolene van Eerden wants to ask, why are mines not making more use of modern technology where huge machines would draw all the water from sediment and recycle this water and reuse it inside the mine operation?
They can.
Yeah.
You're quite right. I think, sorry, just finish the question.
Oh, there is current SA manufacturers of this equipment.
You can you come on and just give the question now and just elaborate on that?
Okay, so she's asking why she's saying that these machines are currently being manufactured in South Africa. So why do mines not make use of them to recycle the water and the sediment?
Yes, you're quite right. And in fact, over on the East Rand, there are, in fact, Greenock LTA have installed some of those to recycle that water. Again, it's not taken to potable, you can't drink it, but it's certainly good enough to discharge into the rivers. Quite right, that is the case. The problem here is we're not talking about treating the water. We're talking about the water that's contained on top of the dam.
Yeah.
So once it's come off the dam, yes, certainly. Once it's into return water dam, we can treat that water. But the problem we're talking about is the water actually sitting on top of these dams.
Mm.
All right, and that water is going on that dam continuously during the mining operation. As you saw, the slurry, the water is going on top of the dam on a continuous basis. And then you have the rain on top of that.
Yeah.
But you're right, you can certainly purify that water to a degree, so you can discharge into a river or wherever you want. Yes, you can do that.
Yeah.
And certainly we have the technology to do that.
Yeah.
But I'm talking about the water contained on top of those dams.
Yeah.
That's the problem we have at the moment. And that is what gone.
Yeah. And then Heidi asked, why are the homes allowed to be built so close to the dam?
In many cases, these are the people who are working on the mines.
Yeah.
And in some cases, these townships are there before the dam arrives. But yes, certainly in places, and I'm just thinking locally, in Benoni, there's some large dams there where the residents immediately below the dams. And also what's happening, a lot of informal settlements are sprouting up because it's a big area with no one on. And these informal settlements are also sprouting up under these dams. Yes, it should be stopped. This is look, you should control the dams so you don't fail. You don't say, well, the dam's going to fail, no one must live there. The whole idea is to make sure the dam doesn't fail. I know. If you start having dams failing all over the country, yes, then there's a problem. But yes, I don't think you should have residential development below a tailings dam. I don't think so. But it's happened. So if you're going to move all these people, who's going to pay for that?
Yeah, that's another thing. Okay, then we've got another one. What is the most preferred construction position of TSFs, downstream or upstream, or is it mainly driven by the geographical environment?
Mainly driven by geographical environment. Most of the dams we have here are downstream dams. We don't have many upstream dams here. And it's the environment. The majority of tailings dams in this country are built on fairly flat areas, so they look for downstream. So that means you either have a very small dam controlling the backside of the tailings dam or none at all. All right.
Yeah.
So this one here you see is a downstream. We built the dam here, and then the tailings tail off at the back.
Okay, and the second half of that question is, what is the advantage to having them downstream, or is there an advantage to having one over the other?
Not really. You're still trying to contain the material. The advantage of an upstream, you don't have quite as much height of the dam because your material, in fact, is laid out on the existing ground. A downstream like this one is quite a large dam wall because you're containing all of the tailings material. So, but this is mainly what we have in this country are downstream dams.
Yeah. And you showed us earlier that Australian dam that failed, where there was one on top of the other. So Heidi asked, should there be an upper and lower dam according to this? I was also wondering, was that by design, or was it just
No, they're all by design. No, it's not somewhere you don't do it about the sticky packet. No, they're properly designed, these dams. I mean, they are quite.
But the one that had one on top of the other, did they, just in case the one failed, did they put one?
No, it's not in case the one fails. It's just the area of land they're using.
Okay.
So they're not going to relocate a new dam well away from the old dam. They've just added onto it or just attached it to the side of it. We're doing one right at the moment where we have a claim only for the lining is claim, not the dam itself, where they've built one right adjacent to the other. Because your whole infrastructure is there. All your discharge and everything is there. So it's much easier to add just a new one adjacent to the old one. It's not put there in case there's a failure. That's not what it is. That's not the reason.
Okay. And then Martin, sorry, last one. Mandy asked,
no, please don't make it last one. Please interrupt.
What is dumped into these dams that make it so dangerous?
In the mining operation, if you're extracting, say, gold, okay, you use a lot of chemicals in extracting gold, okay, and those chemicals end up in the dam. So that material is fairly toxic. It's not nice material at all. It can have lots of very harmful metals within that material. So you have to contain it, and maybe in many years' time, they'll reprocess that material and extract out of that what is in there, some of the metals, etc. But at the moment, they're just allowing it to slowly dry out. That's what they're doing at the moment. But it's very toxic material. because of the process of extracting the gold or whatever you're extracting out of the mine, the material, you use chemicals to extract that product. And those chemicals go into those tailings dams. So it's not, as I said when I started, it's not just sand. You can't just say, well, I can use it to build with. It's not, it's crushed rock and it has a lot of harmful chemicals in it.
Thank you.
Here's another dam failure. You see quite clearly, very similar to Mary Strait. The front of the dam has failed. The material has flowed out of the dam. And you see the amount of material you're talking about here. It's very, very substantial. And I'll show you just now when it goes downstream what happens to this material. So it's extremely harmful material. Here's another one. So, I mean, it's not as though I can just show you one. I can show you dozens of these type of failures going on all around the world. We had them locally, we had them in Europe, and we had them in South America. These dams are failing, and it is a problem. And if, as going back to what Colin said, if there's a third of all the dams, then we really do have a problem. As far as insurance is concerned, I don't know whether you would insure a dam after it's finished, the mine is finished. I presume not. I presume you only insure it during construction. I don't think you insure it afterwards. I assume a liability policy might pick it up from the mine.
Martin.
Yes.
Yes, just purely from an underwriting point of view. So is it safe to say that the failures are generally caused by lack of monitoring as opposed to the design of the structure? Or is it both?
Yes, at the moment it's lack of monitoring. It's lack of control on the dam. Yes, quite right. Lack of monitoring, not so much the design of the dam.
Yeah.
But saying that, when you do the original design, you have to design for after the mine is finished. So you've got to design going forward. So if we find there's a failure and the mine has not been operational for a couple of years, we will certainly look at the design and say, have you designed it for long term? Or have you just designed it during the period that you were operating the mine? And that's what we do during our investigations, all right? The Mary Strait one, that was an operational mine. So it wasn't a design problem. The contractor was not monitoring the level of the water correctly. So it wasn't the design. But after handover, going forward, design may well come in if they're not designed to be long-term. So yes, that might come into it. And that may be a discussion if you have a liability claim after the mine is closed. I'm not sure, I'm asking the underwriters now, how long is that tail liability policy? Presumably it's on an annual basis.
Yeah, so we obviously it's 12 months, and because it's not a specific tailings policy, it's an annual liability policy, and so
yes,
it's very difficult then to say we would cover the insured for a certain period, because it's an annual policy, and if it's renewed, there's cover, and if it's not renewed, there's no cover.
Yeah, and then
yes,
you can also look at the possible environmental liability policy that
yes.
James and his side work on. So as is like he says, on an annually renewable basis, while the mine is still active.
Yeah.
Yes, but I think that's the point. While the mine is still active, what happens when it's no longer active? Then there's no policy anywhere.
Yeah. Unless you look at care and maintenance, then we look at it on that basis as well for an annually renewable basis.
So you could do that even if the mine is closed.
Yeah, as long as it's been looked after and so forth.
Yeah.
All right. Okay. This was one in Brazil. This was on one of the Vale mines in Brazil. To give you some idea, this material from this dam, it killed a lot of people. I think 270 people were killed. But what happened with this material, it flowed downstream and in fact affected watercourses for a length of approximately 600 kilometers. So that's from here to Durban. So you see the environmental impact can be absolutely catastrophic. And here, I think the question asked before, why are you building towns below a tailings dam? Well, here's a town downstream, and you can see that whole town is completely devastated. I mean, that material has come out of there. You can see, come out top left-hand corner there. It's flowed across the ground, and it's ended up going through this town, killing all the people. Now, that was an operational mine. That wasn't long term. This was an operational mine, was not properly controlled, allowed the dam to fail, and allowed that water and that tailings material to flow out of the dam and cause all that destruction. I believe they've reached a settlement. The last thing I heard, they had reached a settlement of a certain amount of money to pay out to the families. But I mean, here it even took the bridge out. So you can imagine the force of tailings coming down to take that bridge away. You're talking about a considerable amount of water coming down the river. So yeah, that would be an interesting liability claim, where you have 250 people killed, you have a huge amount of infrastructure damage, you have pollution damage. So I believe that Vale have reached an agreement with the government on a payout on this mine. They have 2 of these. I believe there's some discussion on the second one. And if anyone has better information, please put their hand up now. That's as far as I'm aware at the moment. That's the latest situation. You see, just look at the environmental damage there. And that material is toxic. That's not mud. That's toxic material. It's going to take years to clear up.
Martin, someone asked what makes it red. What chemical is that?
It's what the material they're mining. You know, here we're mining virtual sand type of material. There, it's a red material. It's just the type of material that's been mined. That's all. It's got nothing to do. It's not the chemicals. It's the material itself. See how it's flowed down river? I don't know. I got one to the village. Now that's really environmental damage. That's huge damage take place there. And I think just to remind that's kind of picture you need to put on your fridge to say what can happen when a tailings dam fails. That's what can happen. It can cause huge environmental damage and destruction. Here's another one that's failed. You see the bottom corner here. In fact, this one's failed in 2 places, 3. I think 3 places here. It's failed there, it's come through there, and it's come through there. Again, they've allowed the pond here. You see where the pond was? The pond was allowed to come right up against this wall here, and it broke through in 3 places and took that material down. So this is a typical, and this one, you're asking about downstream and upstream dams. In fact, this one has both. You can see that it's totally encircled with a dam wall. All right. Just see the environmental damage here. This one is not only broken through here, it's taken a large proportion of the tailings material with it. It looks like about 1/4 to 1/3 of that tailings material has actually been washed out of this dam. So it shows how that material, how saturated that material is sitting in that tailings dam. It's not as though it's just the surface is wet. That material is wet right through, as you can see here. That material is flowed out through the front of this dam. It takes many, many years. And I think the question was, will it dry up? The question was asked earlier. It will. The surface will certainly dry up, but not the material. It'll take many years for that material to dry. This was the latest one we had in South Africa. I don't know how many were killed here. I think, under question, I think it was only 2 were killed. I think 2 were killed in our latest disaster. But again, look at this. We've got a town right below a tailings dam. So again, devastation. Fortunately, it didn't kill a lot of people, but look at the damage it's caused. Going back, look at the damage that's caused. Having a township or a small town just below a tailings dam, this is the damage you get. Okay, you asked about the red material. There's red material. That's another dam that's failed. Corner has failed here. And you see how quite steep this slope is. This one is grass here. This grass is no grass at all on this one. The material is discharged out. It's taken a whole area of material away. See here, another one. So, you know, we can give dozens and dozens of examples of these dams failing. So it's something we have to address. It's something that's going to get worse and worse as the mines are finished, handed over, and the mine walk away. Who then takes control of all these tailings dams around the country? Another one. And look how far. Look at the area of devastation from there. Huge amount going right down here, right down there, right down into there. Huge area of devastation caused by this failure. Before and after. There's a town below a tailings dam. Looked very nice before, it doesn't look so good afterwards. Again, here is taking off, maybe taking 2/3 of that village away completely. All the houses have gone, left absolutely devastation behind it. But it's changed the whole topography. If you look at the background, he's actually taken away part of that slope of the hill as well. Huge amount of damage. Right, that's the end of my presentation, and doom and gloom. Any other questions now? Is anyone still awake and understand what's going on?
Yes. So Alan asks, does South Africa subscribe to the global industry standard on tailings management? If not, do you think we will at any point in the future?
We are part of the discussion going on at the moment, talking about putting a world body together. We don't, as far as we have at the moment, remember we haven't done all the failures here. We're doing some failures up in Africa at the moment. Doing a very nasty failure at the moment up there with one of the diamond mines. As far as we can gather, the design of these dams is correct. We haven't really found many errors in the original design. Where the errors come over, as Alan quite rightly says, is the management of these dams. And if they're properly managed during the lifetime of the dam, you should not get failures. If you allow the pond to keep away from the wall, allow proper beach area, keep your decant tower clean, allow for heavy rain, if you do what you are meant to do as a competent contractor, no, they shouldn't fail. Yeah. And I showed you some examples where they've allowed the pond to get right hard up against the dam face, and that will cause a failure. So, Alan, to answer that question, are we adhering to it? We can't be, because we have failures. So if we were, we wouldn't have any failures. So no, we're not doing it correctly at the moment. We are allowing failures to occur.
Thanks, Alan McLean, for that question. Eugene from Mellon wants to know, do we know at what speed the material travels?
Very rapidly when the initial failure, because the material is mobilized by the water. It's very wet material. But as I said right at the beginning, it is not sand, it is crushed rock. So the moment it stops moving, it goes hard. Yeah. It doesn't stay soft, it goes hard. And then you can walk on it. It goes that hard. You can walk on it. As soon as the water, within a few minutes, the water is out of it, you can walk on it. But it travels away. You can't outrun it if you're thinking about outrunning it. Could you outdrive it? At the initial burst, no, you wouldn't outdrive it. It comes out fast enough than that. It doesn't trickle out, it comes out. If it trickled out, you wouldn't have all the depths. Because you can say to everyone, it's burst, leave your houses. But if you see this picture here, part of the 250 killed were in these houses. Yeah. So if it was slow enough, you could say, we just burst the dam, please vacate. It's not that. It runs down here as a river of mud, toxic material. Yeah.
Scary. And then Heidi asked, what is the time required to rehabilitate the environment?
Vass happened some years ago, and it's still not recovered by a long way. I would say after a major spill like this, you're talking between 20 and 30 years to put this environment back. Marisprait was slightly different. What happened at Marisprait, the insurers paid out under what we just mentioned, the liability policy, but a lot of people decided not to go back into Marisprait. They took the money and presumably they located elsewhere. They didn't go back into the town. They didn't rebuild those original houses. Mary Strait is still operational as a small village, but a lot of people never went back. So it was not fully rehabilitated as far as the houses were concerned, because people said, I'm not getting back there. I'll take the money and I'll move elsewhere, which I think is a decision I would take.
Yeah, me as well. Okay, and then Heidi asked, Garth Dixie asked, Martin, in your experience, when the TSFs failed, when do the TSFs fail? During operational life cycle or after the closure?
We've had both. This one here, the very bad one at Varley's, both of these, this Varley and going back to our Mary Strait, that was during operation of the mine. That was during operation. The contractor was actually on site when that failed.
Yeah.
What happened here, just a little bit on the inquiry, which I found very interesting. The person operating the decanter at that stage kept coming down every single day to the mine office to see the mine manager to say, you're discharging too much material. I can't handle it. You must reduce the amount of discharge onto the dump. I can't handle it. And every single day he was told to go away. I'm using that language. I won't use the language what he was told to do. So he'd go back onto the dam and try to handle the material. The next morning he'd be down again. And he was one of the main witnesses in the inquiry. And that's where they were found guilty, because they were told, the contractor was told over and over again, you're discharging too much material, all right? And they didn't do anything about it. And he was one of the key witnesses to say, you were warned. It's no surprise here. You were warned over and over again that you're discharging too much material and he can't handle it. And that was quite an interesting inquiry.
So that's a criminal prosecution as well, right?
Yes, yes.
Yeah.
And that's why I put the question to you as insurers. If it's a criminal, I assume you would not pay. You would not pay for the fines or whatever happens. If they didn't go to jail, they were fined.
Yeah.
Yes, but if it's a criminal act, I don't think insurers get involved in the criminal act. You step away from that.
Yeah. Okay, if we can just do one more, because I see that we're almost out of time. Ernest should ask, after the mining has stopped, why
Yes.
can't the tailings not be put back into empty cavities?
Yeah, but, okay, it's a good question. First question, who's going to pay?
Yeah.
If you look at the amount of material you're looking at there, which has taken many, many years to deposit on that dam, who's going to pay for taking that and putting it wherever you're going to put it? A lot of this material comes from underground as well. So
why
how are
can't
you
they
going to put it underground?
Yeah, but Martin, why can't they include it in the project cost?
Well, then the cost of mining, you would not have a mine.
Yeah.
You know, the gold mines at the moment are marginal here in this country. They're very marginal because we're going deeper and deeper. So the gold mines are marginal at the moment. If the gold mine had to allow for taking all that material and putting it back underground, then you couldn't mine. The cost of mining would be prohibitive. You couldn't allow for that.
Yeah.
So the mine, in fact, wouldn't exist because you couldn't allow for the cost of putting all that material back underground again.
Yeah.
And as I said right at the beginning, you can't dig a hole and bury it because then you've got the material from the hole.
Yeah.
So, you know, we've got these vast structures all around the country and all around the world, not just here, that we have to do something about. We have them now and we're making them every day. We're making them bigger and bigger. We have to think about them because we're going to have more and more of these failures going forward. We have to, because no one's looking after them. So we have to have these failures. They're going to occur. And where it's a big open area with no town, okay, it's environmental damage. But where you have a town like this, well, then there's a big problem.
It's a problem. Yeah.
It's a problem.
Thank you, Martin. This was very, very informative and interesting and scary as usual.
I hope no one jumps off a building now. So
Jump off a tailings dam.
yes, jump off a tailings dam. Yeah. Well, thank you everyone for listening. I hope everyone kept awake. And